Chapter 5 is, I would say, one of the most important chapters in this course, because finally we can talk about the make of the network security protocols using cryptographic building blocks that we talk about in chapters from 2 to 3. I'm sorry, chapters from 2 to 4. So we now put things together, and then we can see how, in practice, these cryptographic building blocks are used. We have already seen IPsec, which is a major security protocol that we are using for VPNs, for establishing VPNs, virtual private networks, which is at the network layer. And on top of that, at the TCP layer, we saw SSL, how we can secure how can we secure TCP packets at that layer. And last time, at the application layer, we talk about how to secure email, how to secure emails using these cryptographic building blocks. Today, we are going to look at Kerberos, which is an authentication protocol at the application, at the local area network. This is also at the application layer. So first of all, we would need to imagine, we need to see in the area network what types of authentications we need. So in the area networks, of course, there will be several servers on the local area network, NAN, that provides services to you. For instance, you have an email server, you have a web server, you have printing server, you have all sorts of other servers you may think of. For instance, some of the education tools, software. So all of these servers are necessary to carry out our routine work. So for each of these servers, when you want to use the services these servers provide to you, of course, one of the things you need to do is to authenticate yourself that you are a legitimate user to use these services. Okay, so now let's see. On the area network, of course, when you first log on to the system, to the network, you will need to put in your login name, your user name, and your password. So that was the most used authentication methods when you first log on to a computer system. Of course, you can also use other methods such as fingerprints or some other things like your smartphones now provide, right? But when you, let's say this is the first time you log on to the local area network, but when you use a particular service from a particular server, that means you need to do that again. If you don't have other mechanisms that make it easier for you, right? So for instance, if I want to use an email account service, then maybe I would need to do the same thing, right? Either by typing my username and passwords, or if I have to swipe some patterns or put my fingerprints, that kind of thing, to authenticate myself. So imagine if you have to use all kinds of different services, that means you may have to do this authentication steps many times, and that is very inconvenient. Okay, so the goal of Kerberos is to make this process easier. So the goals here is, okay, authenticate users on a local area network without using a PKI, without using public key certificates, without using public keys, and without public key infrastructure. So what you're using is anything that you're going to use is based on your user logins, your username, and your password, and you don't have to do this often to use services provided by your local area networks. Okay, so that's the important thing. Okay, so first of all, you are not using public key cryptography to authenticate yourself. And second, okay, so you are allowed to access those services without authenticating yourself for a very long period of time. For instance, maybe 8 hours or 12 hours. So you just need to log into your LAN first. Okay. So Kerberos uses semantic key encryption and electronic passes called tickets. Okay, so basically, what it means here is that when you authenticate once, then your credentials will be recorded in the form of tickets, and you can reuse that tickets to authenticate yourself to get services. All right. And it uses two different types of tickets. One is called TGS ticket. The other one is called V ticket. So TGS stands for ticket server. The other one is this V stands for a server for other services such as email or web. And Kerberos was devised by a group of people at MIT in the 1980s to meet the demand of using different types of services from different servers on a local area network without using public key authentication. Okay. So the setup of Kerberos servers requires two special servers to issue tickets to users. And one is called AAS. So this is AS server. This is authentication server that we know that we use when we log on to a LAN, meaning your usernames and your passwords. And we have another server called TGS. Now, these two servers are part of the Kerberos. Okay, so TGS is a ticket granting server, which manages servers on the local area network. So then we also have two types of protocols. One is called single realm Kerberos. The other one is multi-realm Kerberos. So now let's see how Kerberos works. So at first logon, the user provides username and password to the authentication server, AS. AS then authenticates the user and provides a TGS ticket to the user. So this first step is what we normally do. So when we first want to log on to a particular system, in this case is a LAN system. So I would put in my username and then type in my password, and then I get authenticated, and I am allowed to use the services of this LAN provides to me. Okay, so that we know. So then once authenticated myself, once I authenticated myself to AS, then AS is going to issue a TGS ticket to me. And I can use this TGS ticket, which is in an electronic form, to authenticate myself to the other servers. That way, I don't have to retype my username and passwords every time I use the services provided by other servers. Okay, so that's the third bullet says. So now let me switch from me to user, right? So when the user wants to access a service provided by server V, the user provides the TGS, its TGS ticket. Okay, so that's another server. So that TGS ticket has my credential. And when the TGS sees it, TGS knows I have already authenticated myself to AS. Then TGS authenticates the TGS ticket, and issues a V ticket for that particular server V. And that ticket is passed on to the user. The user then provides that V ticket to server V. So that tells V that the user has been authenticated. Then V, of course, then can provide the service to the user. Okay, so what Kerberos does is to use semantic key encryption algorithms, and of course it also uses timestamps. Okay, and so now let's see some of the parameters or notations that Kerberos uses. Okay, so now U indicates user, and V indicates server. ID sub U is use ID, okay, user use ID. And ID sub TGS is is server TGS ID. T sub I is timestamp. E sub K is a semantic key encryption with a secret key K. K sub U is the secret key derived from user use password. And K sub U comma TGS is the session key generated by the AS server to be used by user U and TGS server. K sub TGS is the master key shared by AS and TGS. K sub V is the master key shared by TGS and V. And then K sub U comma V is the session key generated by TGS to be used by user U and server V. Capital LT sub I is expiration time of a ticket, and ticket sub TGS is the TGS ticket itself issued to user U by AS server, authentication server. And ticket sub V is the server ticket for using service V, which is issued to user U by the TGS server. And AD sub U is user U's MAC address. Okay, so the machine address of user U's computer. Auth sub U comma TGS is the authentication code generated using secret key K sub U TGS. And auth sub U comma V is the authentication code generated using secret key K sub U comma V. Okay, so so those are the parameters and notations that Kerberos uses. As you can see here, the building blocks are straightforward. Encryption algorithm, basically just encryption algorithm with timestamps. And the authentication algorithm used in Kerberos is a key-based authentication, secret key-based authentication. Okay, so that means, for instance, the master key shared by AS and TGS needs to be set up beforehand. So when you set up Kerberos system, so this will be set up. And also the master key shared by the TGS server and server V on your LAN is also set up when you set up the Kerberos system. Okay, the session keys of course are generated using these master keys in the protocol. So now let's look at a single realm Kerberos system. So this is a diagram. Okay, so this is supposed to be one local area network, which is served by one Kerberos. Okay, we call it single realm Kerberos. So these AS and TGS could be run on one machine, but now for the conceptual purpose, okay, so we are separating them. Okay, so we have an AS server that, of course, is in charge, is authenticating, is responsible for authenticating users. So this is the users' computers on this area network. Okay, and the TGS server is responsible for managing or authenticating users to these servers. So we have a email server, database server, file server, and a web server, right? Now you can think of other servers, okay? And between AS and TGS, they can communicate, okay, using a master secret key. Okay, they can authenticate each other using a master secret. All right. So now let's see the data flow diagram or authentication flow. So let's say this is user computer. Let's say it's Alice's computer. So she logs on to the local area network by authenticating herself to the AS server, right? So step one, authenticating herself. And then AS, after authenticating Alice, then AS will issue a TGS ticket to Alice. And when Alice wants to use one of these services. For instance, let's say she wants to send an email. So then she will make a request, okay, say to TGS server, indicating that she wants to send email. And then TGS looks at her ticket, TGS ticket, authenticating Alice, and issues a TGS ticket for the email server and issues back to Alice. Then Alice presents that V ticket, right? Issues for this email is a V ticket. Then Alice presents that V ticket to the email server, and then the server looks at the V ticket, authenticates Alice, and then allows Alice to use the software, the email software here to send email. So basically that is authentication data flow. So now let's look at the actual components of each items in this authentication process. In a single realm Kerberos, there are 3 phases. Okay, so as we saw earlier, phase 1, phase 2, phase 3. So now we're going to look at details of each of these items. Okay, phase 1, Alice, okay, the user U, first authenticates himself or herself to the AES server upon verifying the user's credential, which means checks his password. AES issues a TGS ticket to user U. Okay, so that's basically what phase 1 does. So U sends in a request to authenticate U to AS, which is puts in use ID and indicates TGS ID, which TGS, and then timestamp 1. Okay, so now this request, when you first log on, basically that's when this request should be sent. So that's when that happens, there's a timestamp, T1. So AS, and then checks, okay, this user's authentication because the user has his password, and then sends this TGS, this TGS ticket called ticket sub TGS, okay. So now let's first see what is a ticket. Oops, sorry. Let's see what is a ticket involves. Okay, so what is involved here is user's ID, user's address, MAC address, TGS server's ID, and timestamp 2, and expiration time for this ticket. So this is when this ticket is issued, and this is when this ticket should expire. So the most important part here is a section key, K sub U comma TGS. So this is a section key. So now maybe we go back to see this. So this is a section key for user U and TGS server, which is generated by AS server. Okay. So this is generated by the AS server. So this is the most important part. Okay. So this is a ticket, of course, that cannot be seen. This ticket is supposed not not seen by other people. So right, so by other users. So it needs to be encrypted. Okay, because this is the authentication how this authentication relies on. So then, of course, it will be encrypted using a encryption algorithm. Using the, excuse me, let me go back to this. Okay, so so this KTGS, this K should be sub TGS, okay? Because so this is the key. We are here. We have the K sub TGS, okay? So this is the master key shared by AS TGS. In here, so this TGS should be a subscript of K, okay? So this is a master key shared by AS and TGS, okay? So now it sends this key, this whole ticket, so which is right here. So this ticket includes a section key to be used by user U and TGS, okay? But at this moment, okay, when the users gets this ticket from AS, the user cannot see what this ticket is, okay? So what he gets is a section key, okay, shared. I'm sorry, hold on. What he gets, okay, so now this ticket itself has to be encrypted because now, so that the user cannot see the whole thing. I mean, cannot modify this key, okay? So this key cannot be modified by the user, just in case somebody else intercepts this message. Okay, so the user cannot modify it, but the user would know what this section key is because he's going to use it between so this is a section key between user U and TGS server. So this is another thing that U gets. So the section key to be used before the user, between the user and TGS server, and indicating, so this key is for this particular TGS server, ID TGS. It has a timestamp, same timestamp. So T2, which is when this ticket is issued, and expiration time. Again, this section key should not be seen by anybody else except user U and TGS server. So now it's encrypted using key K sub U, okay, which is a key generated based on user's password. So the user can decrypt this message. Okay, the user, when user U gets this, the user can decrypt this message, extracts this section key between user U and TGS server. And it also has this ticket. Now, again, this ticket cannot be modified by user U, okay? Because it has been encrypted using K sub TGS. Okay, so now in phase 2, so this time the user wants to use a particular server V. So what user does is to send a request to TGS server, indicating that user V's service is requested, and there's a ticket TGS is presented in this request. So that right here. So there's a request. Because now remember, this ticket can be reused many times as long as is not expired, okay? So every time the user wants to use a particular service, the user will reuse this ticket. Phase one is only done once in one particular Kerberos section. So that will be for a long period of time, such as 8 hours, as we said, in a working day, or 12 hours, or whatever, right? So it's a long period of time. But this phase two is whenever user U wants a particular service, the user reuses this ticket, ticket TGS, okay? So this is to authenticate you to TGS. And then it also includes a authentication between you and TGS. So this has user use ID, user use machine address of user's computer, and then this is when this service is requested. So there's a timestamp string, T3. And this is now encrypted. So when this encryption actually serves two purposes. So nobody sees this, and also this is authentication. So this using key K sub U, comma TGS. Okay, so using this key. Okay, so now this key is used. All right, but of course, TGS does not know this this key, but this key can be obtained from this ticket, right? So that's why this ticket is included here. So TGS will first use the master key, okay, between AS and TGS to decrypt this ticket, extracts, okay, this section key, extracts this section key. So then TGS can decrypt this in the ciphertext, because now he has this key. So now he sees this request is from user U with a timestamp 3. So then, of course, the user U, if this process is successful, user U is authenticated. Okay, and then in this request, there's IDV indicating the user wants to use the service provided by server V. So then TGS generates a V ticket, okay, and sends it to you. So that's ticket sub V. So this is a V ticket. And of course, as you can see here, the most important part is a section key it generates between user U and V. And now the other information indicates this is for user U, okay, user U's ID and his MAC address of the MAC address of his computer, and server V, and then this ticket is issued at timestamp T4, and expiration time for this ticket is LT sub 4. The whole thing now is encrypted using key K sub V, okay? And so that V, server V, so this is a master key, can decrypt this message, this master key between server V and TGS server. And this K sub U comma V is for the user. So the user should be able to get this back, okay? So this should be authenticated and so should not be seen by others. So that means now it will be encrypted using the section key K sub U comma TGS obtained from this step. Okay, so then the user U can use their section key to decrypt this message, get this section key between U and server V. Okay, so that's what phase 2 does. Phase 3 is for the user to authenticate herself to server V. So let's say user is Alice. So Alice sends a request to user V indicating Alice wants to use the service provided by V. So for the authentication purpose, she presents ticket sub V that she gets from TGS server to V, and also includes its authentication code encrypted using this section key K sub U comma V, which server V does not know yet, but the server V can get this section key from this ticket, and this ticket is encrypted using the master key between V and TGS. So that's how authentication is done, right? So all these steps, all the authentication parts are done using secret keys. And all of these is based on users login information. Okay, so now see this authentication code. So this is user ID, MAC address of user use computer, and this is timestamp T5 when this request is happens, and then the server V can extract this is section key from this ticket V, decrypt this, okay, and then he knows this from user U, okay, and then to finish this protocol, V then sends a timestamp T5 plus 1, okay, to user U, which is encrypted using a section key K sub U comma V between U and V. So then, so this Kerberos, we can think of it as some sort of a handshake, but it establishes authentication. Okay, so Kerberos is finished, and then user U is allowed now to use the service provided by server V. So again, as you see, the protocol itself is not hard. Technically, it's not hard. Okay, it uses basic cryptographic building blocks. So most of these is just encryption algorithm and key generation algorithm, and mechanism is timestamps. Right? So that's a single RAM Kerberos. So we can extend this single RAM Kerberos to multiple RAM Kerberos by extend a single RAM LAN to multi-RAM LANs. So you may imagine that, for instance, in a setting of the university, a department like computer science department has its own local area network, and the computer engineering department has its own local area networks, and both networks have provides different services. Okay, suppose a person on the computer science LAN wants to use a service provided by the computer engineering LAN. Since it doesn't have a direct, so since AS of the second network, LAN, cannot authenticate the user in the first LAN. So there will be some mechanisms to allow this authentication to proceed. So this is called multi-RAM Kerberos. So here we have two RAMs. RAM A, let's say this is computer science LAN. RAM B, let's say this is computer engineering LAN. They belong to different departments. And actually at UMass Law, they belong to different colleges too. Okay. So let's say they have these services. And let's assume that a person, let's say Bob at this time, in the second RAM wants to use a service provided by the first RAM LAN, okay? But Bob does not have credentials in the first RAM's authentication server. He does have credential, of course, at the second RAM's AS server, authentication server. So then, of course, he would first need to authenticate himself, and then he will get a ticket, okay? But this time he will say, I am not going to use the service in his own RAM. Instead, he wants to use a service in a different RAM. So then he will send this ticket to the TGS of the different RAM, obtain a server ticket for that RAM, and then present that server ticket V, ticket sub V to this server in a different RAM. Okay, so basically that's a simple extension, but it involves one more phase. Okay. All right, so let's see the details of multi-RAM Kerberos. There are 4 phases. Okay. And so phase 1, so upon the user authenticates himself to its local AS. So the local AS, after authenticating the user, issues a local ticket, TGS ticket to user. So this is the same as before in phase 1. But phase 2 this time wants to use a server in a neighbor LAN. So in this case, local TGS issues a neighbor TGS ticket to user. So of course, these when you set up multi-RAM Kerberos, TGS between different LANs should share the same master key. Okay, so share the same master key, and so that master key is K sub TGS prime. So this is the master key shared by 2 TGS in neighboring RAMs. Okay, so oops. So this is again, you know, that so that the neighboring TGS can decrypt this message and get this section key for you and the neighboring TGS. So okay, so that's also easy to understand. So and then in phase 4, okay, so this is the same in phase 3 in single RAM. The only difference is now it uses a neighboring RAM's V. Okay, so that is multi-RAM Kerberos details. So with this mechanism in place, users do not need to re-authenticate himself each time to obtain a particular service provided by his local area network. All right, so that is the end of Kerberos protocol. Again, this is at the application layer for local area networks. So that, of course, then it can authenticate users based on users' login passwords. Okay, so that is the whole idea of Kerberos. All right, so that is the end of this video. I'm going to see you in the next video. Goodbye.